Hey guys, so welcome back to your next class of Catalyst Concepts. So in the previous session, we looked at what exactly is the meaning of the electric power term. Right? We figured out what are the units of measuring the electric power. We came up with the phrase of watt, right? It's measured in the unit watt, is nothing but joules per second, right? So that is what is when 1 joule of work gets of electric power is being used. So in daily life, we use electricity every day. That's quite a common thing that we know. If you ever pay attention to your electric bill, you'll hear the word or you'll see the word called unit somewhere. Okay. We say 1 unit of electricity or 2 units or per unit charges this much, something like that. Right. So what exactly is this unit talking about in terms of our electricity consumption? Okay. So they say 1 unit is basically what we call as a bigger unit, a unit of power called kilowatt hour. Okay, kilowatt hour. Now we know what is 1 kilowatt, right? We spoke that if a watt is small, then we kind of just take a bigger unit of watt called kilowatt, which is nothing but 1,000 watts, right? So if you use 1 kilowatt of power in 1 hour, then you say that you're using 1 kilowatt hour of energy. Okay, so 1 kilowatt is used in 1 hour. If you have to kind of measure exactly how much energy it is, so I can say 1 kilowatt hour equals to 1 kilowatt into 1 hour. Okay, so I'll write this 1 kilowatt as 1,000 watts into 1 hour. Now hour is basically we need to change it from hours to second. I know 1 hour is 60 minutes, right? And if I have to convert minute to second, I'll again multiply with 60, right? So this is how I'll do it. So this 1,000 watt I can write as 1,000 joules per second, and this into 6 are 3,600 seconds. Joule per second and into second. So basically the unit over here second will get cancelled out, and what will remain with is 1,000 into 3,600 joule. Basically 360000 joules. Okay. So when this much energy is used or this much work is done, or let's just say energy, electric energy is used, then we'll say that 1 kilowatt hour, that is 1 unit of electricity, has been used. Okay, so generally we write, since there's like so many zeros, we tend to write it in a shorthand form like this: 3.6 into 10 to the power 1 2 3 4 5 6, 10 to the power 6 joules. Okay, this is nothing but 1 unit of electricity or electric power. All right, so depending on which appliance it is, it has different units of consumption, right? For example, fans over the month, they'll have a lesser units used than something like, let's say, an AC or a geyser or a toaster or an oven, right? The bigger the appliance, the more units it's going to use up throughout the month. And ultimately the ending of the month, how many units has been used in your house, based on that you get your bill. All right. So, however, sometimes what happens, you'll see there are some electric issues in your house. Okay. Sometimes your transformer outside the house blows up, or sometimes maybe some appliance in your house might as well go out. Right. It can damage your electric. We sometimes call it a spike also. But the correct term we are going to use is overloading. Okay. So what is this overloading of current? Okay, we know the word load. Load is basically anything that is on the circuit that uses the electricity. In our circuit diagrams, we put like this symbol for load, right? It could be a bulb, it could be a fan, anything. So generally what happens is the electricity that you get in your house is being generated in an electricity generation plant, right? And in that, from that plant all the way it comes to your house through the electric wires. See, on the street you will see these high tension wires, they're just kind of like on the top, right? So these are called as these are actually wires that have very less resistance and they carry higher voltage of current. Okay, the since the power is resistance is less, the current is high in that, which is why you see that caution 440 volts board and all of that. So you should, even by mistake, you shouldn't be touching those wires. Once this power comes to your house, it comes through a transformer. The transformer is going to shift the voltage a little bit down to what we use in our daily in our houses, which is nothing but somewhere between 220 volts to 240 volts. Okay, it's not a constant thing, somewhere between 220 to 240. Generally we consider it as 230 or 240 volts. Okay, on an average you should be getting somewhere around 230 volts at any given time in your electric circuits. So when you have a certain amount of voltage, your appliances can be drawing current on them. Okay, so these wires, once they enter your house, they come as two big parallel wires. Okay, you have two big parallel wires that are coming inside your house. So I'm just going to draw them like this. Okay, one for going in and one for going out, because we know that it has to be a closed loop. So I'm just going to put it something like this for now. Okay, this is going in, going out. Now, any appliance that you connect in your house has to be connected between these two wires. Okay, say for example, I want to attach a fan over here. Okay, say I'll call this a fan. Say I want to attach a tube light here. Okay, say I want to attach AC here. Okay, say that I want to attach one oven or whatever. Okay, throughout your house there are multiple appliances. All of them, if you look at this diagram, they're actually connected in a parallel connection, because this is the connection and they are all parallel branches to it. What that means is, whenever we have parallel connection, try to recollect, we say that the voltage is constant but the current is not. Okay, so the voltage will be constant for all the appliances, for all the loads more specifically. Okay, so now if we are assuming this 240 volts of voltage, meaning my fan has the same voltage, tube also has AC, and oven also has the same voltage. However, the voltage is only going to give you a certain amount of current based on your resistance. Okay, based on your resistance you will get a certain amount of current. For example, if the fan's resistance is 240 ohms, for example, okay, we know V equals to IR, right? I equals to V by R. So that means if I want to measure the current, I know the voltage, which is 240 volts. I just divide it by the resistance that it gets. So if, for example, if it's 240 ohms, that means current is nothing but 1 ampere. Okay, so any appliance with 240 ohm resistance will drag out 1 ampere of current from the from these wires. Okay, depending, again, each appliance has its own resistance, we know that. So depending on each resistance, each appliance, different currents will flow to different. and more the resistance or the different the resistance, the different is going to be the current. Say for example, we know that tube lights may use a little more current. Okay, so let me assume something like 3 amperes. Okay, AC takes up a lot of current, let's say 8 amperes, or let's just call it 12 amperes. Okay, I'm going to say 12 amps, and oven, let's call it 6 amps. Okay, or let's make it 4 amps. Okay, so now if I look at this, uh, there's a total amount of current being dragged through my uh, entire house. Okay, if I look at it, 12 plus 4 plus 3 plus 1, 12, 16, 19, 20. So currently I am dragging 20 amperes of current in my house. However, there is a certain limit that your wiring can handle. Okay, your wires can handle only a certain amount of current. That will all that information will be there on a meter box. So your house has a meter box. In that meter box, you will see exactly how much current can be handled by your house. So generally, say that you have something called 20 amperes. Okay, let's assume the limit is 20 amperes for now. Okay, which means if your house or your appliances are taking more than 20 amperes of current, it means we are overloading the circuit. Okay, if you're crossing the higher limit of current, it means you're overloading your circuit, meaning there are too many loads on it. So in these four, if I add a new appliance over here, like let's say geyser, which needs like say 5 amperes. Now my total is 1, 12, 15, 16, 20, 25. And say all of them are on at the same time. Okay, keeping the appliance is fine. Only when it is on is the problem, because that's when it takes current. So now I have 25 amperes of current, which means that is an overload, and what happens is now it's going to start damaging my electric circuit and my appliances. Okay, so to avoid all of this, we have something called fuses in our house. Okay, you must have seen a fuse, MCBs, RCBs, whatever those fuses are, or even devices have fuses. Okay, so we have something called a fuse at the starting where the current is coming in from. Okay, if the current is coming in from here, the fuse will be here. What the fuse will do is, it's a very thin wire compared to the remaining wires in your house. Because it's a thin wire, it can only handle so much current. If there is more current than it can handle, meaning if there is an overload, this thin wire is going to melt or break. Because of the high amount of current and the heat it generates, it's going to break. Because the fuse breaks, your entire connection is becoming an open circuit, meaning no current can pass through it, because there's just no way for the current to come here once the fuse is broken. Okay, so due to that, this wire is going to be gone, but at least all of your appliances get saved. So ultimately, it saves your, that one little wire is going to save your entire house from getting damaged. Right, so this is what overloading is and how do we avoid overloading using fuses. That's it for today. This is actually the end of your chapter. So if you have any questions, comments, doubts, just drop them in the comment section below. And I'll see you guys again in the next class. And please prepare for your final assessment, which is going to be tomorrow. Okay, then. Thank you.